Let's take a look at 2.2. So we're going to look at graphs of functions. So basic parent functions and their graphs. All right, some of the basic functions that we have that we're looking at and that we will be graphing. We've got lines. So let's say something like this, right? There's a line. In fact, you know what? Let me just make a mini sort of coordinate plane for our example here. So we have lines. Here's an example of a line. An equation for lines tend to be some value, x squared plus another value. Ooh, not squared, excuse me. So x to the 1 power plus another value. Right, like y equals mx plus b. That's supposed to be an m, not an a. Y equals mx plus b. So those are linear. That's one kind of a basic function. Another one that we see a lot are quadratics. So ax squared plus bx plus c equals 0. So quadratic. So we have examples. That's a common quadratic we see. For function, by the way, these are functions we're looking at. There are different graphs that are not functions, but we're focusing on the graphs that are functions. Here's another option, going downwards. And for example, here's another linear option. Okay, so there's some generic options. What are other functions we have? Well, we have the absolute value functions. And those are like y equals absolute value of x. And some other forms of that, but that's a basic general one. And here's an example of the absolute value, as well as another option we could have for an absolute value function. And then the next function that we would have, or pretty much the only other one we're going to be focusing on at this time in this class activity, or sorry, lecture video, is the square root function. So y equals the square root of x. Now notice this is a square root. So if we were to solve for x, we would end up getting something, if we squared both sides, we'd end up getting something like y squared equals x. So this is sort of, it's the sideways parabola. Okay, so there's two basic options. We have that sideways parabola, and maybe this sideways parabola, or the bottom half of either one of these. Okay, so these are the four basic ones we're going to see in this lecture video. Options for functions and their basic parent graphs. Okay, so notice parent graphs are based at the origin. Okay, they hit the origin. All right, so here we go. We're going to be graphing by plotting points. So first thing you always want to do before you just jump right into the problem is, do you recognize the graph? So take a look at the equation. Which one of these equations does your equation fit? Very good thing to look for, okay? So key things to look for. What are the exponents? Is there x squared in there? Do you see absolute value symbols? Do you see a square root? All of these have characteristic things you want to look for. The next thing you want to do is identify the key points. So look for your intercepts and your vertex and so on. For a linear equation, you wouldn't be looking for a vertex, but for a parabola, you would be looking for a vertex. All right, is there any symmetry in the problem? So you might want to look for symmetry. And do you have enough points to determine the graph? So that kind of depends. Remember, for lines, we tend to just work with 3 points. For parabolas, I would go with 5 if possible. And then absolute values, I'd hit maybe between 3 and 5 points. And square roots, I'd probably try about 3 to 5 points as well. Just as much as you can to get a good idea of what the graph looks like. All right, so here we go. Example 1. We're going to graph this function by plotting points. And then we're going to state the domain and range, and we'll check our graph using a calculator. All right, what kind of a graph does this look like? Kind of a function. Well, if I was to go up and look at my examples, it looks like this one. It's going to be the square root function, which means it's going to be that sideways half of a parabola. Okay, so I have a basic idea of what my graph should end up looking like, which is really helpful. So let's go ahead. I'm going to create my x values. And then I will be inputting my f of x values, which tells me I'll take my x value and subtract 1 from it. So we want to be kind of careful when we're choosing values for our graphs. You want to think about what the graph is and what the characteristics are you're looking for it. But in general, we do try for the intercepts. So x equal to 0. That would be one intercept to try for. We can also try for the other intercept, but we'll do that after on a separate side. And then the other points I like to try for are maybe like 1 and 2. Yeah, let's go with 2. And then let's try some of the negative values. Oh, interesting. If I was to pick a negative value, -1 minus 1, I would have a negative under my radical. So I actually can't pick any negative values. Because remember, we can't have negatives under our radicals. So let's just go ahead and keep with the positive numbers. 3, 4. How many is that? 1, 2, 3, 4, 5. Yeah, let's go with 5. Alrighty, plugging this in. It's going to be the square root of 0 minus 1, which is going to equal the square root of, -1. That doesn't exist. Okay, it's not a real number. So we actually don't have any x-intercepts. All right, interesting. Let's try 1. So 1 minus 1 is going to end up equaling the square root of 0, which is 0. And while we're doing this, let's go ahead and create the coordinate point that we are working to find. So this was 0 and square root of -1, which we're not going to graph, not a real number. And the next point we have is 1, 0. Okay, let's find the next one. So it's going to be 2 minus 1, which is going to be square root of 1, which will equal 1. So we have the point 2, comma, 1. Go ahead and try 3 and 4 by yourself and see what you get. All right, so doing that, we have 3 minus 1, square root of 2, which we can sort of approximate with our calculator when we want to graph it. Remember, we only use the approximation when we're graphing. You do not give your answer as an approximation unless told otherwise. So normally you leave it as the square root. 4 minus 1 is going to equal the square root of 3. So we'll go ahead with 4 square root of 3. And let's go ahead and graph these points real quick. I'm going to get rid of some of that extra space there. Okay, graphing these points. That one we cannot graph. So next one, 1, 0. 1, 0, right there. And then let's see, 2, 1, 2, 1. And next one, 3 square root of 2. Ooh, what is square root of 2? All right, I've busted out my graphing calculator. Let's do square root of 2. So 2, we're going to raise that to the second, or the half power. And there we go, 1.41, so about 1.5. Remember, when we're graphing, we can be approximate. So that's going to be, I'll just write out my approximation on the side for graphing. I said that was about 1 point, let's just go with 4. So 3, 1.4, about there. And then let's go ahead and approximate this. Remember, we're just doing that for graphing. So I want the square root of 3. So 3 to the 1 divided by 2 power. Oops, and 1.73, so almost at 2. 1.73. So it's, as we go to 4, we're almost at 2. All right, and these, it's kind of hard to see the points here, but if you can label your points, that would be great. So this was 4 root 3. That was 3 root 2. The other point was 2, 1. And this one was 1, 0. And remember, I know what the basic look of this graph is. It's that parabola that curls, it's the halfway one. So more than likely, it looks like the blue one. And we can check our answer with our calculator. But there we go. And now we're going to pick our we're going to state our domain and range. So the domain, we could go ahead and find it how we've been doing before, algebraically. You know, where we set what's underneath, we want that to be greater than or equal to x minus 1. But we could also look at our graph. Our domain, remember, are the x values that my graph uses. So what x values does my graph use? Well, my x values start at 1, they include 1, and then, reading my x's, they continue on to positive infinity. So we used our graph to find our domain. Let's go ahead and use our graph to find our range. Okay, so range means we're looking at the y values. So do I use any negative values? No. Bam. Here's a y value I use. I use 0, and I am including 0. Okay, so 0, and then continuing upwards, I go, and you might wonder, am I hitting any of these upper y values? Well, remember, this value here will continually, slowly, gradually rise higher and higher and higher. We just don't have enough room to show it. So that will also be rising towards positive infinity. And there's your domain and your range for this function. Okay, let's go ahead and check this with our calculator. All right. So assuming none of you have played around with a graphing calculator, I'll just go through how to graph this. All right, so to do graphing, we're going to go to y equals. You see that button right there? Whack that. And you can see we have places for quite a few functions that we could plug in. How many functions? 6, 7, 8, 9, 10. A lot of functions we could plug in. But we're not going to do that many. Ooh, a termite. The bugs are just attacking me right now. All right, we're just going to plot 1. So what is the equation I'm plotting? Well, I'm plotting x minus 1 and the square root. And remember, I can rewrite that as x minus 1 to the half power. So I'll go ahead and use that to graph with. So open parenthesis. Now, when you're graphing with your calculator, parentheses are your friend, but they're also a slight bit of an enemy because if you forget one somewhere, things can go wrong. So just count your parentheses. Now we're going to do x minus 1. Oh, real quick, also note. See this minus sign there? That is different than this. This is a negative symbol. That is a minus sign. Okay? So we used the minus sign. And then we're going to raise that to, so close parentheses, raise it to the, now I'm going to use my parentheses again. Let me back this up so you can see what the calculator's doing. Okay, to the half power. So 1 divided by 2, close parentheses, and I'll just drop down. All right, so we have put in our function, and we're going to go ahead and hit graph. Aha! And there my graph appears. Is that what I have? Yeah, that's what I have. So if you want to change your window, or how many, notice I only have 1, 2, 3, 4, 5 tick marks up and 5 tick marks to the side. Our graph here is 1, 2, 3, 4, 5, 6, 7. 7 by 7. So if I want to change my window, I'll go ahead and hit window. And this tells me the minimum amount of x values I'll have, the minimum and the maximum amount of x values. So you could choose to make your negative x values smaller and your positive x values larger, and vice versa for your y values. You could also choose to change your scale. So instead of going by 1s, you could choose to count by 2s, by 3s, and so on. I'm going to keep with a scale of 1, but I want to change my window to 7s, because that is what my graph here has. So this is where you're going to use your negative symbol. Okay, we're going to hit negative 7. That's the smallest x value I want. The largest one I want is positive 7. Okay, I'm going to go ahead and change my y values. So the smallest one I want is negative 7. Once again, hit that negative, and then 7. And the largest y value I want is positive 7. Okay, so I have changed my window. Go ahead and hit graph. And there she be. All right. So that is how you can change your window to check. And I'll hit clear, and I'm back to the normal calculating page. All right, so notice, did we have a y-intercept? No, we don't have any y-intercepts. That was not a real number, but we do have our x-intercept. So this is my x-intercept. But our y-intercept did not exist. All right, let's go ahead and graph the next one. Let me go ahead and zoom in. All right, do we recognize this equation? Absolute values already. Remember, absolute values. These are the parent graphs for it, either up or down. The basic ones for y equals the absolute value of x. Okay, and remember, we're looking at functions right now. There are other kinds of graphs, but we're searching for functions. So we're going to go ahead and plot some points. Okay, now the question we might ask ourselves is, are we going to run into problems when we pick a number, like how we did for the other problem? Because remember, for our other equation, we couldn't pick negative numbers because we started to get imaginary numbers or non-real numbers, so we had a problem there. But for absolute values, do we have any problems for putting in any kind of number? No, you can take the absolute value of any number. Okay, so we don't actually have a restriction on the numbers we can input for x. Let's go ahead, and I just like to pick some small negative values, 0 as always, and then the positive values. And normally, because our graph isn't that large, I stick to some smaller numbers. And as time goes by, maybe you'll find a number that you realize you couldn't actually work with, so you might have to erase and go back and pick a different number so you can work with that. Sometimes it is a bit of trial and error. All right, so plugging this in, that's 2 minus negative 2. Ooh, need the parentheses there. Absolute value of negative 2 plus 2, which is going to equal 0. And here's my coordinates section. Please remember to write this down when you're showing your work. All right, negative 2, 0. Let's do the next one. Negative 2 minus negative 1 equals negative 2 plus 1, which is going to equal negative 1. Go ahead and try the other three and check your answers with me after you've unpaused the video. All right, negative 2 minus 0 equal absolute value of negative 2, which is 2.